So I did a little calculating with the help of my installation, my mirror of Paul Falstad's simulator, and by trial and error, I homed in on 31.072 AUG, the wire gauge for a 40 inductive coil. A 40 Henry coil will produce 160 ohms of resistance per 40 Henrys, a 4 to 1. So I transferred that information over to here to help me remember what I'm doing as in the course of my fiddling with this thing. So that's what it means in practical terms. So I have 160 ohms of resistance on each coil. Here's the series resistance right here, is 160 ohms for VC2 and also VC1 for that matter. I use the same model. So I just arbitrarily picked a value of 4 to 1 rather than 3 to 1, and then I had to figure out what the wire gauge is, and that's a gauge of about 30 or 31, a gauge of 31 magnetic winding wire. So for the purposes of this demonstration, it gave me the kind of values that I wanted to achieve, namely, well, not this. And this is not very deterministic because I only did an 80 millisecond trial run. But negative 55 megawatts is what I'm overproducing at the moment. And then, so my RMS amperage between the two coils, coil 1 and 2, is 7.8 kiloamps. And then the voltage is 11.75 kilovolts. And then when I do the math and divide 11 by 7.8, I get 1.5. So that's a 3 to 2 relationship. That is so close to my target of 1.67. That's good enough for me. So now I have to bring it down. And so what I'm going to do is lower the frequency. Try lowering the frequency and see what that does. It should do it if it doesn't crap out on me. You know, sometimes if you go too low, then the thing dies. The surge just disappears. And then you got to think of some other solution. But I'll try that and see what happens.